Hi guys, today we're going to talk about the last topic within the quadratics unit, which is average rate of change. Average rate of change should sound kind of familiar. We've talked about rate of change. So if you think to yourself, where have we talked about rate of change and what is the meaning of rate of change? We've talked about it with linear functions, and it really just means slope. Okay, it's a term that represents the word slope, which is steepness. So we've looked at it before with linear functions. So if you look at a line, and we've talked about the properties of the rate of change, which is that if you looked at the slope or the rate of change between any 2 points, like the first two that I just plotted here, or the second two, or any, right, or like from the first to the third, think about what will you notice about the rate of change in a linear function. And that is that in a linear function, the rate of change is constant. It's the same. But if a function is not linear, like if it's a quadratic, and really this can apply to any other type of function, like we've talked about exponential functions, this could have been taught to you in exponential functions. The rate of change is not constant. That's why it's not a straight line. So if you look at a quadratic function, which we know to be the U shape, the rate of change or the slope is constantly changing. Okay, so the rate of change changes throughout. It's not the same. I think I spelled that wrong. No, I spelled it right. It keeps throughout the function. So depending on where you are, which points you're looking at, the rate of change continuously changes, and there are infinitely many rates of change. So what we do is we talk about instead of the actual rate of change, we talk about the average rate of change when a function is not linear. So it's actually quite simple. And again, this could be done with any type of function, not just quadratic functions, but you're going to be given 2 points. You're going to be given those x values, and you could be given the graph, or you could be given the equation, or you could be given the table of values. I have an example of each. And you're basically just going to ignore everything that happens in between, because you can't possibly account for all of it. So you're going to ignore all of these values in between, and you're going to basically pretend that you're going on a straight line from the red point to the red point, from one point to the other, and you're just going to calculate the slope. And that represents the average. So you're not actually doing an average. Okay, so there's no use at all of the formula that you would use for an average, but the average represents basically from start to end, from one point to the other. The rate of change between those 2 points is the average for that whole interval. Okay, so take a look at example 1. Consider f of x whose graph is shown below. Find the average rate of change from x equals 1 to x equals 3. So I give you an x value of 1. Oh, let me use pen. To an x value of 3. So what you're going to do is you're going to basically just take those 2 points and calculate slope between them. And that will be the average slope or average rate of change between those 2 points. So you're going to figure out the coordinates. I have 1. I figure out the y value when x is 1 is 1, 0. And then when x is 3, the y value of the function is -4. And I'm just going to do slope formula. Change in y over change in x. Okay, so 0 plus 4 over 1 minus 3. That gives me a slope or a rate of change of 4 over -2, which is -2. And that kind of tells me some information. It tells me that between those 2 points, that negative tells me that the values are decreasing. Okay, because it's negative. So it's telling you that function, remember we talked about increasing and decreasing, it tells you that the function's decreasing over that interval. That's what that negative means. But again, this is the average rate of change between those 2 points. Okay? So you could see this through a graph. You could see it in an algebraic equation. Given the function f of x equals -x squared minus 6x plus 2, find the average rate of change from x equals -5 to x equals -2. This also could be written as x between -5 and -2, like that. So or you could see it as interval notation. I could say from -5 to -2. So there are different ways of representing that interval. They're all an interval from one x value to another. Again, you're not calculating each, because you can't, there's infinitely many x values in between. So you can't calculate all those individual y values. You're just going to take the two y values on those two endpoints and do slope formula. Okay, so when x is -5, I'm going to find the y value, and when x is -2, I'm going to find the y value. This time I don't have a graph, I have the function. So I'm going to plug in -5 into the function. Y equals -5 squared minus 6 times -5 plus 2. So that's going to be -25 plus 30 plus 2, and that's going to be 7. So when x is -5, y is 7. And then for the second one, -2 squared minus 6 times -2 plus 2 is going to be -4 plus 12 plus 2, and that's going to give us 10. So when x is -2, y is 10 on this quadratic function. And again, the average rate of change is just the slope formula between those 2 points. So change in y over change in x. And again, I know I'm repeating myself, but it's really important to understand. I could have given you something that's not quadratic. I'm doing it within the quadratics unit, but I could have given you an exponential function, and it would be exactly the same process. Okay, so I'm going to subtract 10 minus 7 over -2 plus 5. That's going to be 3 over 3. So the average rate of change is 1. It's positive. That tells me that the function is increasing from -5 to -2. Okay. All right. Last example. This time I gave you the interval written this way as an inequality. Why don't you guys pause the video and find the average rate of change? Okay, so average rate of change, I have a table. So I have this pair, -3, 8, given to me, and all the way to 9, 5. I am going to ignore all these other values. I don't need them. I'm just going to calculate the slope between those. So change in y over change in x. All right, so I have 8 minus 5 over -3 minus 9. That's going to be 3 over -12. And that is -1/4. That's my average rate of change. All right, so for tonight and in class the rest of the day today, I have a review sheet with additional review problems on the quadratics unit, and then mixed in there you have some average rate of change problems. So it includes everything. Good review for your upcoming test, which again is going to be moved to next week. All right, guys, I will see you tomorrow. Bye.